Anybody fraction strips? Are we needing any help there, or is it, if we would have given you pattern blocks instead of fraction strips, it would have been okay too? You're all right with those? Let's ask this question. I think you had a question on the homework. Is there ever a time when you're dividing when the only thing you're concerned with is the remainder? You don't really care about the quotient? Was that question on there? Did anybody come up with anything that would work, May?
Basically what I did, I was thinking of, counting pairs and stuff like that, and when you divide, you're taking out students, and then you figure out how much will be left over after the end of the night. You can figure out, you can divide how much each person got, how much it costs, figure out how much money you had left over, or food you have left over.
So a situation where what's left over. Okay, Kelly?
I did one for like the more personal thing.
Okay.
I did like you're making cookies for a party and you want to know how many you can eat and there's still enough for everyone else.
Okay. So you're going to take enough for so many per person at the party.
Yeah, like there's like 2 per
But you don't even care what, you just care how many are left over for
Yeah.
you.
Yep.
Okay. All right. Anybody think of another situation where the remainder might be the critical part? Keep watching it for real life situations where the remainder is what we're after. Also, on your homework, we gave you some questions about time. It's such and such time right now. What time will it be in this many hours? Have you got that? Somebody got that handy to get those figures that I gave you off of the assignment? I guess I can look it up. It's 3 o'clock. It's 3 o'clock. What will it be in what? 11 hours. Could we have somebody that hasn't been to the board yet come up and share how they got the answer to this? Jamie, do you want to come up?
So I just pictured a clock, and so 3 o'clock is right here. And I knew that in 12 hours it would go all the way around the clock. So 11 hours is just one less than 12, so I just went back 1, which would put you at 2 o'clock.
Okay. Did anybody think of it a different way?
I kind of thought backwards where it's 3 hours from like 3 hours ago it was 12 o'clock, and then if you minus 3 from 11 it's 9, so then minus 9 from 12. I went somewhere around there. Yeah. Oh wait.
Think through it again.
Okay.
It's 3 o'clock.
Minus 11.
What time will it be in 11 hours?
8 hours, so. So then I went from 12 o'clock minus. Okay, now I'm getting myself confused.
Okay.
Like I just I thought about how many like from 3, like how much can I add to 3 to get to the 12, and so that's 9, and then 2 more would equal 11 from the 9, so then that was 2 o'clock.
So you broke this up into how many will get to back to the 12, and then
Get back
how many
to-
left?
Right.
Okay, there's another way of thinking about it. Anybody else try anything else than one of those methods? How many of you made a clock and counted around it? Drew it out, several of you? Or pictured one at least in your mind? Okay. And there was another one that, after that, what was it? It's
8 hours.
8 hours ago. It's 3 o'clock. What was it? This would be in. This is 8 hours ago. Let's hear somebody. They're thinking on this one. Nobody did any thinking on this one? Tiara?
I just did the same thing with the clock. They don't need to go.
Yep.
Okay.
Yep.
Can I just put it here? That is on this wall?
Sure.
Okay.
I think everybody can see that wall as well as.
And then, so, okay, so I were going 8 hours backwards. I just did like with the clock before. I just went back 8 and was able to hit 7 o'clock.
You show us how you did it?
So going back 8 hours, you just went backwards, so 2 to 1, 12, 11, 10, 9, 8, 7.
Oh, no, that's 8.
How do you know that's 8? Just going back hours, like an hour ago from 3 o'clock would be 2 o'clock. An hour past that would be 1 o'clock.
Yeah.
So 8 times. 7.
The reason I'm saying that is when we went back, like you went 2, 1, 12, 11, like, so how did you know when you got to 8 hours?
Oh, okay. So I would just like,
Does everyone see what I'm asking?
Yeah.
yeah. So like, you mean like 1, 2, oh, okay. 1, 2, 3, 4, 5, 6, 7, 8. Yeah.
Okay,
There we go.
all right.
Awesome.
The reason you did it that way is because you knew where you needed to end up, right?
Yes.
Okay. Did anybody do it differently than counting back on the clock like that?
It's funny because I actually realized, like, since you have, hold on, let me read. So I realized, that if, okay, let's say it's 3 o'clock and we're saying, we already know, we've already talked about that the answer was 7. And so we realized if we go back, you know, like she just showed, you can count and you'll get to 7. But if you go forward and you count, that's 4. And it made me realize, like, you know, since there's 12 hours in the clock, like if you take the difference, like instead of saying 8 hours ago, if you say, okay, well 8 minus 12 is 4, then you can just go 4 forward and get the same answer. Does that make sense? So I took the difference, since I realized that there's only 12 hours total, and I subtracted 8, and I said, okay, then 8 and 4 add up to 12, so they're gonna land in the same spot if we're adding or subtracting from 3. Does that make sense?
Who followed her?
Kind of.
Would it work every time? Would her strategy work every time?
Yes, because.
So you're
if you
saying
take-
that 3 subtract 8 is the same as 3 add 4?
No, not. I mean, it's.
This
not-
is a
it's not like
subtract
negative
problem, right?
numbers. It's not like we have negative numbers because it's a clock. But in a sense, yes, because when you're subtracting 8 from 3, you're going backwards on the clock, and that will take you to the 7, which is the same as the 3 taking you to the 7 going forward. I realized this because my friend is in Paris right now, and she's 8 hours ahead of us. And I got like, so we would text all the time, and I realized like it was easier in my mind to subtract 4 hours from what time it is for me now than it is to add 8 hours. So like right now, it's 10 o'clock. Instead of me going, okay, so I have to add 8 hours to that, I can just subtract 8 hours and realize, okay, it's afternoon though. But anyway, so that's what made me realize that difference. Do you have a question?
Well, it's just like what we did with the in 11 hours. Instead of adding 11 hours to 3, I took away 1 hour to get 2. So it's the same thing, just in reverse.
Okay. Today, we're going to build off of that introduction. We're going to do what is called clock arithmetic. Other names that are used for clock arithmetic are modulo arithmetic, or remainder arithmetic. Those three names are synonymous. Question: will problems like this, will you be working on teaching those in elementary school? Those of you who are going to be teaching elementary, are these appropriate kinds of teaching situations? Definitely. Well, today we're going to not only work on how it works with our clock and how you might use it to teach your elementary school students, we're going to look at it a little bit differently as well. Let's take another situation. Anybody ever, is anybody in here in the Guinness Book of World Records? No? Okay, neither am I. Let's just say you want to be. So you decide you're going to do, you and your roommates are going to do something the longest. Okay? I don't know. Jump rope or whatever you, I guess that's in there somewhere. And let's just say you decide to start at 10 o'clock at night to launch this, to begin your, so you have this big feast right before it to get it all ready. And then there's going to be continual jumping, and you're going to go as long as you can. I don't even know what the record is, but we'll just say that. So let's say you started off and you go for 7 hours straight, just jumping rope. And then you do this tag team, you touch and they come in and they start. The next person, they say, I'm going to outdo you, so they go for 8 hours. Okay? Your next roommate comes in, they can only go 6 hours. Okay? And then somebody comes in after 4 hours, they aren't feeling too well. And then let's just say that somebody goes for 10 hours. And that's the record. What time is it? You started at 10 o'clock. What time is it when you broke the record?
9.
It's 9 o'clock, somebody said? Hmm? How did you get it? Anybody?
I just counted.
What do you mean?
So just started at 10 and went 11, 12, 1, 2, 3, 4, 5.
Holding up your fingers, and then
Yes, restart.
5, and then what? Sit
6 and 8.
all the way up. Okay. Anybody else?
I put the 6 and 4 and 10 together, and then took 4 from the 8, so that's 24 hours. And then I just counted.
6 and 4 and 10,
And then 4 from the 8.
and 4 from the 8. That's 24 hours. That leaves
11.
4 plus 7, 11 more. So if it's 10 o'clock and you go 11 more, that would be
9.
9. Everybody hear how Melissa thought about it? Could we make a clock and do like Tate did, just kind of count around it? 1, 2, 3, 4, 5, 6, 7. Then from there, 1, 2, 3, 4, 5, 6, 7, 8, and so on. Would that work? Okay. Well, what about this? 10 plus 7 plus 8 plus 6 plus 4 plus 10. What do we get?
45.
We get 35. Since there are 12 hours in our clock, if we take 35 and divide it by 12, we get what? 2. Remainder.
It's 45, not 35.
It's not 35?
That's 45.
It's what?
45.
45. Yeah, it's 35 hours later, so this is 45. 45 divided by 12 is 3, remainder
9.
9.
0.75.
0.75 because it's 9 twelfths, which is 3/4, which is 0.75, right? Is everybody with me? Here's the answer. It's 9 o'clock. It's our remainder. Hence the name, remainder arithmetic. Now, let's have you try it with another situation. Let's do this. Here's how we'll write it. All right. This says it's 7 o'clock. What time will it be in 8 hours? But this number we put a little subscript on the operation, says our clock is not a regular clock with 12 hours. It's a clock with 9 hours on it. Okay? So, So 1, 2, 3, 4, 5, 6, 7, 8. It's a 9-hour clock. And we start here and we go to 7. 1, 2, 3, 4, 5, 6, 7. Then we add 8. So from there we go 1, 2, 3, 4, 5, 6, 7, 8. The answer is 6. So if it were 7 o'clock and you jumped for 8 hours, it would then be 6 o'clock on this 9-hour clock. Did everybody see how we got it? We just made a clock and counted around it, starting at the beginning. Now, that's one way to do it. Use a clock. We're actually using a number line, but it's a circular number line, right? We just keep going. Use clock as a number line. That's one method. Here's the other method. We take 7 plus 8 is equal to, in our system, that's 15, right? But it's clock 9, so I'm going to take 15 and divide by 9. And all I really care about is the remainder. So I don't care that 9 goes into 15 once. I just care that there's a remainder of 6. Does that make sense? Can you see that we got the very same answer as we got using the clock? Now, we need to make one adjustment on this clock and all the clocks that we make. Question, comment?
So, question, so for that one, 15 minus 9 is also 6. Is that just coincidence or would it work with subtraction as well?
It would work, but we need to get you into the mode of dividing by the clock, or the modulus is what sometimes we say. Since when you divide by 9, you don't ever get a remainder of 9, right? Because if you got a remainder of 9, what would you do? You'd go in one more time, right? So what they do is they change the, like, instead of the 12, there should be a 0 if we're using clock arithmetic with our clock. Because if it's 4 o'clock and 8 hours later on a regular clock, what time will it be? 12. But if I take 4 plus 8 and get 12 and divide it by 12 and write the remainder, the answer is 0. Well, 0 and 12 are the very same time. Does that make sense? So, do you remember how in bases, like in base 7, there's no such thing as a number 7, it's just 0 through 6? Clocks are like bases in that way only. Okay, that if I'm in clock 9, there isn't a 9 because you can't have a remainder of 9 with 9, because when you divide it by 9, it would have gone in one more time. So the only remainders you can get are 0 through 8. Does that make sense? All right. Well, let's try. So we can use the clock as a number line. What was the other method I showed you? Add, divide by what? What do we divide by? The clock number, right? And write what? Remainder. So there's a couple of ways that you can add, and one can double check the other. Now let's try this one. 7 subtract 8. What time would it be if it was 7 o'clock? And I said, well, I've been doing this for 8 hours. What time did I start doing it? In other words, 8 hours ago. Somebody got an answer? Katie, how'd you do it?
Well, I thought about kind of how the same thing with 12 and 11, like on the clock, it's just one back. So here, 8 is just one away from 9, so I just went back one. Instead of
You went back one. From where?
from 7.
Back is this way, isn't it?
No, okay, so forward.
Forward one.
Yeah.
Oh, okay. Did anybody else get 8? How did you? Go to the menu end and do what? Subtraction means what? Go the other direction, right? We go 1, 2, 3, 4, 5, 6, 7, 8. The answer is 8. Make sure you write this little 9 down here, because if somebody walks in and sees 7 minus 8 equals 8 on the board, they're going to go, what? Okay. So, use clock as the number line. Up here, what did we do? Start at first add end, and then what? Go clockwise, how far? Second add end distance, right? Here, we're going to start at the menu end and go what? Counter clockwise. How much? Whatever the subtrahend is, right? Distance of the subtrahend. Okay. Let's talk for just a minute about fact families. How many of you have heard of them? Some of you kind of wanting to raise your hand, but there is an arithmetic fact. Okay? How many members are there in every fact family? 4, always. So somebody give me the other 3 members of this fact family. You guys have done this, haven't you? You better have.
5 minus 2.
5 minus 2 equals 3 is a member of that fact family. There's 2 more members. What are they?
5 minus 3.
5 minus 3 equals 2. What's the 4th one? 3 plus 2 equals 5. Every fact family that has addition or subtraction has 4 members. 2 of them will be addition, 2 of them will be subtraction. In the addition, they'll be identical except for the add-ends will be switched. We call that the commutative property. The subtraction, the the minuend will always be the sum of the, and then you can switch places with the 2 add-ins to be one the subtrahend and one the difference, or vice versa. Does that make sense? So, most students conceptually can do addition better than they can do subtraction, right? most of you are probably in that category as well. I say most because there's some that maybe aren't, but most people have less trouble with addition than they do with subtraction. So what I'd like to do is, I'm going to put a blank here. We'll pretend we don't know the answer, even though we do know it's 8, right? By doing it by this method. What I'd like to do is I'd like you to help me write down the other 3 members of this fact family. If I've got a subtraction, the 3 missing ones, 2 of them will be addition and the other will be subtraction. So let's go, come on. Quit being so hesitant. 8 minus 7 equals blank. Is that one? You're shaking your head. Why not? Samantha?
Well, because, it,
because otherwise you changed it to only 7 numbers on the clock. Instead of 8 numbers. Or
What do you mean we
like,
changed it?
there's 9 numbers on,
There's 9 numbers on the clock. One of them is 0.
but one you're starting at 7 and one you're starting at
Yeah. Is this a member of that family?
yes.
You're shaking your head, Ellen. What?
Well, you get 2 different answers. With those
Oh.
2 different-
That's how you know it's a different family.
Yeah.
This one was 8, and what's this one?
1.
It's 1 o'clock, right?
If you
So they can't be the members the same.
if you look at that fact family,
Let's look at the pattern here.
the subtraction equations, they
These
have
two?
the same minuend.
They have the same minuend. Do these? That's characteristic of every fact family. So what have I got to do here? Have a 7. What do I have to do here?
Minus the blank.
Blank, and this will become 8. Can you see the pattern? The minuends never change for your 2 subtractions. Okay? Give me the addition ones. 8 plus blank equals 7 and blank plus 8 equals 7. Now, why are we doing this? Because this problem right here, or this one, probably this one, because we're going to go to 8 and say, what do I have to add to 8 to get back to 7? So here we are at 8, and I'm going to add, which means I'm going to go which way? Clockwise, and I'm going to count, and I need to get to 7, my answer. So 1, 2, 4, 5, 6, 7, 8. What did it take me to get to 7? 8. Therefore, that is the answer to this one because it's the answer to that one. And therefore, it must be the answer to this one. Because all of them are members of the same fact family. So we've got to use the... Does that make sense? Let's try another one. Let's do 2. Subtract 5 in clock 7. Do it using this strategy. write a missing add-end problem. That's what we did. We wrote a missing add-end problem, and then we thought about the problem in terms of addition. We solved it using addition. Who can come up and rewrite this as a missing add-end problem from the same fact family and then solve it with that? Yeah, go ahead, Rebecca. Is that the same family? Okay. But that's not an addition problem, right? Are those the correct members of that fact family? Yes, they are. How can we tell? Because the sum is the minuend on both of them, right? Okay. Now, pick one of those that would be easiest for you to solve and solve it. Except change the 7 to a 0. Good. All right.
So I'm gonna do this one. So we go from 5 here, we're gonna go clockwise instead of addition. So 1, 2, 3, 4. So
Do you agree that 4, adding 4 onto 5 gets her to 2? Okay.
Yeah.
All right. Well, if 4 goes in that blank, then 4 goes in the top blank. Well, actually all the blanks, right? Because it's the same fact family. So therefore, we know that this problem right here is, the answer is 4. How did we think about it? We thought about it as a missing add-end problem from the same fact family, and we did it in really with addition, but with, okay? Let's go back up and verify it using this. Who can do that? Who can do the first method? Oh, this method for this problem. Just to double check it.
Using a number line?
Using the clock as the number line. Okay, come on up. So she started at 2, went back 1, 2, 3, 4, 5. Where did she end up? 4. Okay? Can everybody see that's 2 different ways of thinking about the same problem? This one was a takeaway using a number line. This one was write a missing add-in problem and think of it in terms of addition. What would I have to add to 5 to get it to end up at 2? And here is the third way of thinking about subtraction. And I'm going to use Morgan's before I use Morgan's example from her homework, I want to do this. I was over on that board and I wrote down 4 subtraction problems, and then I wrote down 4 addition problems. You'll remember it went something like this. That's the same as negative 11 plus 3. And we define subtraction as really being adding the opposite. So here I have this negative 3, and here's the 3 as the opposite. The other name for opposite is additive inverse. Same word as the opposite when we're talking about our whole numbers and our arithmetic. Now, we know this is true, right? Well, in the clock, it was 3 o'clock, right? And 8 hours before, we said was what time? 7 o'clock. Well, subtraction is just like adding the inverse. So I'm going to say 8 inverse. The way you write inverse is with this little symbol. Well, what is the additive inverse of 8? Well, in order to answer that, we look here, additive inverse is opposite. But in clocks, there's no such thing as negative numbers. So we couldn't say negative 8. So, we need a definition for this word, identity. Anybody know it? The identity is the do nothing. So what's the do nothing for addition? 3 plus does nothing. 0. I could put negative 7 plus, if it does nothing to the number, what is it? 0. Identity, do nothing. The additive identity is 0. Okay? The inverse, the definition for inverse, let's write it up here, is the, we could say number, but then it doesn't apply. The element, the thing that yields, gives, equals the identity. This definition is the definition for inverse. So if I'm looking for the inverse of 7, 7 plus its inverse yields, gives the identity, which we said was 0, right? So, what goes in the blank here?
Negative 7.
Negative 7. How about negative 5 plus what gives the identity? What goes in there? 5. That's why the additive inverse is the opposite. Because the opposite, when you add it with the number, always gives the identity, making it its inverse. Because the inverse is the thing that produces the identity. All right. I'm looking for the inverse of 8. Well, The inverse of 8 will be the number which I add to 8, and it gives me the identity. Now, what's the identity for clocks? What could I add to any clock number that does nothing, that leaves it the very same? See it? 12 if you are a 12 clock. But 12 is the same as 0. So 0 is the identity just like it is with. So, what number goes in the blank right here? 4. Why?
Because 12 is the same as 0.
Because 8 plus 4 divided by 12 gives me a remainder of 0. So the inverse of 8 is 4. So up here, 3 plus, what's the inverse of 8? 4 equals 7. That's why the answer to this is 7. So therefore, 3 minus 8 equals 7 in clock 12. Does that make sense?
How did you figure out 4 again?
I asked, in clock 12, what would I have to add to 8 to give me the identity of 0? And it is 4, because when I add 4 to 8 and divide by 12, 0 is my remainder. All right, let's apply that. We already have done this problem, 7. We've already done this problem, 7 minus 8 in clock 9, 2 different ways. We counted back on the clock. We did a missing add-in. In both cases, we got 8. Let's apply this new method here. Change subtraction to adding the inverse. All right. So subtraction is the same as adding the inverse. The inverse of 8, I don't know what it is in clock 9, but I can find it because the inverse, what? Is the element that gives us the identity. So 8 plus something in clock 9 gives me 0. 1. How do we know? 8 plus 1 is 9. Divide by 9 leaves a remainder of 0. So if 1 is my answer, then I'm going to change this to a, instead of writing inverse of 8, I'm going to write 1. And I do 7 plus 1 is 8. Divided by 9, write the remainder. What do I get? 8. Same thing we got the other 3 methods. You with me? Let's do it with this problem. 2 minus 5 is the same as what? Help me. Plus the inverse of 5. I don't know what it is yet, right? So let's come down here and figure it out. How do I figure out what the inverse of 5 is in clock 7? 5 plus something gives me that identity. 2. If 2 works here, then 2 is the inverse of 5. So I'm going to go 2 plus 2. And what do I get when I add 2 and divide by 7 and write the remainder? 4, which is the same thing Jessica got here, and the same thing, who did this one? Rebecca got here. There's 3 different ways of showing the difference. Who wants to ask a question? Yes.
I kind of had another way that I did the problem.
I'm interested.
Okay.
Can everybody see this is exactly what, that's what you were doing over there,
I
reading.
just didn't know how to
Yeah,
Should I just?
anywhere.
Okay.
Which problem do you want to work?
So let's just take.
Okay, the clock one?
Yeah.
So this is 3 minus 8 in clock 12.
Right. So you have 3 minus 8 in clock 12. And so what I did is like just normal 3 minus 8 is negative 5, right?
Oh,
And then I
okay.
just added that to how many was in the clock. And you get, that's 7. And then that's the answer.
What do you mean? 12's in the clock.
Right, there's
Oh,
numbers on
the
the clock.
12.
So you would like just
Oh, add
subtract
the
these
negative
normally.
5 and the 12.
Yeah, and add the negative 5 to the number here.
Hmm.
And then you get 7. And that's been working for all of them.
For all of the clocks.
Mm-hmm.
So,
So
you
like
went
if we
into the
do
negatives.
7 minus 8 in clock 9, then we have, so 7 minus 8 is negative 1. So you add that to 9, and it's 8.
Is the final answer.
Right. So, and that's just a lot faster to me than the missing adding or the inverse thing. Might be more confusing, but it's, I don't know. It's more mental math, it's easier.
You what? Why does it work?
Because if you are subtracting this and you get the 5, because then you're like, if it's a negative, then like you already like reached 0. So like, if you subtract 3 of these, then it's 0. So what you have left over is negative 5. And so then you're just going back from the 0 or the 12 5 times. So it's like adding negative 5 or subtracting 5,
Okay.
which gives you the answer.
Okay. Thank you.
I did basically the same thing as her, except I didn't want to deal with negative numbers. So I just took, so like how it says 12/8, or to the 8, you know? You just take the 8 and you subtract 3, and you get 5.
That's a
And
positive 5.
Yeah, that's a positive 5. And I just know that when I'm subtracting, so when I'm adding, I'm going clockwise. When I'm subtracting, I'm going to go counterclockwise. So I'm going to start at what the hour is, so 12, and you just subtract 5 from it.
Hmm.
That's what I did.
Okay.
So I just did the same thing, except I didn't want to do it like this.
Do I care if you use your own method? You know by now that I encourage your own method, right? But I need you to know what fact families are. And I need you to be able to take a subtract problem and write it as an addition problem to be able to find that. I need you to know how to do that. I also need you to know that subtraction is the same as adding the inverse for integers as well as clocks. So I may ask you, do this problem and do it in this method. And I'll need you to do that. If I give you one and I don't give you a method, you do whatever you understand best first. In fact, you might do your method first, then do the method that I ask and see if you get the same result. And then you go, oh, I'm really confident with my method, so now I think I've got the part he's asked me to do correct as well. Does that make sense?
Yeah.
All right, tonight I'm going to actually ask you to do it in these different methods. So follow it, make sure you know what's going on.